The word of trigonometry comes from Greek. Trigonon means triangle and metron, which means measure. Trigonometry is the study of relationships between side lengths and angles of triangles. Let's start with a simple right angle triangle ABC with the right angle at C. So let's call an angle ABC, which is theta, and we have the adjacent side of the angle theta is side A, and the opposite side of the angle theta is side B, and we also have C as the hypotenuse. We have some definitions. The first one is sine. Sine of the angle theta equals to the opposite side over the hypotenuse. The opposite side of the angle theta is B and the hypotenuse is C. So sine theta equals B over C. The second one is cosine. Cosine of the angle theta is defined as adjacent side over the hypotenuse. The adjacent side of the angle theta is A and the hypotenuse is C. So cosine theta equals A over C. The third one is tangent. The tangent of the angle theta is defined as opposite side over the adjacent side. Because the opposite side is B and the adjacent side of the angle theta is A, so the tangent theta equals B over A. To memorize the definition, some people will call SOHCAHTOA. S is for sine, O is the opposite side, H is the hypotenuse, C for cosine, A for the adjacent, H for hypotenuse, T for tangent, O for the opposite, A for the adjacent. We also have some definitions which are the reciprocal functions of the previous three ratios. The first one is cosecant. Cosecant of the angle theta is 1 over sine theta. And the second one is secant. Secant of the angle theta is 1 over cosine theta. The last one is the cotangent. Cotangent theta equals 1 over tangent theta. For trigonometric ratios, the Cartesian diagram is divided by 4 quadrants. In the first quadrant, sine theta is defined as y over r, cosine theta equals x over r, and tangent theta equals y over x. For the second quadrant, we have sine theta equals y over r, cosine theta equals negative x over r, and tangent theta equals negative y over x. For the third quadrant, we have sine theta equals negative y over r, cosine theta equals negative x over r, and tangent theta equals y over x. For the fourth quadrant, we have sine theta equals negative y over r, cosine theta equals x over r, and tangent theta equals negative y over x. So from here we can conclude the signs of trigonometric functions. For the first quadrant, all of the trigonometric functions are positive. For the second quadrant, only sine is positive. For the third quadrant, only tangent is positive. And for the fourth quadrant, cosine is positive. Example 1. In the diagram, P negative 7, 24 is a point on the circle with the center at the origin O. Find the values of sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. According to this diagram, from the point P, we have x equals negative 7 and y equals 24. To find out the radius, or r, we have to build a small right angle triangle here. So based on the Pythagoras theorem, we will define r equals square root of x square plus y square. Substitute the values of x and y, so we will have r equals negative 7 square plus 24 square, and then take the square root. By the calculation, we will have the value of r equals 25. So from here, we will define some trigonometric functions. For sine, cosine, and tangent theta, directly substitute the value of x, y, and r. Sine theta equals y over r equals 24 over 25. For cosine theta equals x over r. So cosine theta equals negative 7 over 25. Tangent theta equals y over x. Tangent theta equals negative 24 over 7. Directly, we have the reciprocal function. Cosecant theta, secant theta, and cotangent theta. Cosecant theta equals 25 over 24. Secant theta equals negative 25 over 7. Cotangent theta equals negative 7 over 24. Using a calculator, find the values of the following correct to 4 decimal places. A. Cosecant 128 degree and B. Secant 249 degree. Part A. Firstly, you have to make sure that your calculator is in scientific mode. Make sure that your calculator is set in DEG mode. DEG stands for degree. We input 128 cosecant function in the trigonometry button. So it will be 1.2690. Part B. Secant of 249 degree. Input 249 degree and find the function secant in trigonometry button. So the result is negative 2.7904. Example 3. If cosine theta equals 4 over 9 and theta is between 0 degree and 90 degree, find, without using a calculator, the values of sine theta, cotangent theta and secant theta. The solution. Based on the question, the angle theta is between 0 degree and 90 degree. And from the question, we obtain that cosine of the angle theta equals 4 over 9. From here, we have x equals 4 and r equals 9. Using a right angle triangle with the angle theta, x equals 4 and r equals 9. Remember, x is the adjacent to angle theta. Based on Pythagoras theorem, we obtain that x squared plus y squared equals r squared, y squared equals r squared minus x squared, and y equals square root of r squared minus x squared. Substitute all the values of r and x, y equals square root of 9 squared minus 4 squared. By the calculation, the value of y equals square root of 65. Sine theta equals y over r. Substituting the values of y and r, we will obtain sine theta equals square root of 65 over 9. Tangent theta equals y over x. But in the question, we are asked to find the cotangent theta. Cotangent theta is 1 over tangent theta equals x over y. Substitute the value of x and y. The cotangent theta equals 4 over square root of 65 equals 4 square root of 65 over 65. Cosine theta equals x over r. Secant theta equals 1 over cosine theta equals r over x. By substituting the values of r and x, we have secant theta equals 9 over square root of 65 or 9 square root of 65 over 65. If tangent theta times secant theta is less than 0, determine the possible quadrants in which the angle theta lies. Here is the solution. Firstly, be familiar with the sine plus, which is larger than 0, and sine negative, which is less than 0. Tangent theta times secant theta is less than 0. So there are two possibilities. The first possibility, if tangent theta times secant theta is less than 0, so tangent theta is positive and secant theta is negative. Since secant theta is negative, and secant theta is also 1 over cosine theta, so we can conclude that cosine theta must be negative. Since tangent is positive and the other functions are negative, so the angle on the third quadrant. The second possibility, tangent theta times secant theta is less than 0, tangent theta is negative, and secant theta is positive. Remember, if secant theta is positive, cosine theta must be positive. Since cosine theta is positive and other functions are negative, so we can conclude that the angle is in the fourth quadrant. Sometimes you have to know some special angles in trigonometry. This is some tables consist of special angles from 0 degree until 360 degree for sine theta, cosine theta, and tangent theta. Example 5. In the diagram, AD equals 6 cm, angle CAD equals 45 degree, and angle ABC equals 60 degree. Find the exact lengths of CD, AC, and AB. Here is the solution. For part A, focus at the triangle ADC. So this is the triangle ADC with right angle at D. Now we have that angle A is 45 degree. The length of AD is 6. The opposite side of the angle 49 degree is CD. So from here, we will obtain tangent theta equals opposite side over adjacent side. So from here, we obtain tangent 45 degree equals CD over 6. Now take a look for the special angles table. You will find that tangent 45 degree is 1. 1 equals CD over 6. From here, we obtain that CD equals 6 cm. Focus at the triangle ADC. Based on Pythagoras theorem, we have AC square equals AD square plus CD square. AC equals square root of AD square plus CD square. Substituting the values of AD and CD into the formula, we obtain AC equals square root of 72 or 6 square root of 2 cm. For part C, focus at the triangle BCA. This is the triangle BCA with the right angle at C, and the angle B is 60 degree. So from here, it is easier to verify that sine theta equals opposite side over the hypotenuse. The hypotenuse is AB. From here, we know sine 60 degree equals 6 square root of 2 over AB. Using the table of special angles, you will find the value of sine 60 degree, 1 over 2 square root of 3 equals 6 square root of 2 over AB. So from here, we obtain AB equals 4 square root of 6 centimeter.